Hi folks, Pedantic Skeptic here, and we are going to just keep moving along in our response to the Apologetics Session 35, Origins and Evolution Part 2 by Cornerstone Church. We are about a quarter of the way through this cringe fest right now, and so we will see how far we get. In this one, I don't know, but we will just see what happens. So let's get into this. All right.
Back to these two kinds emerging from this kind and that kind emerging from this kind and so forth.
I went over this. I think we got a couple of seconds behind. So let's see where this goes next.
So we will talk about chemical evolution later.
Yeah, we got to this point. Chemical evolution isn't a thing.
I probably won't get to it today, but that's the origin of first life, and
No, it's not.
we are going to talk a bit about kind of the difficulty, the leap, the faith that it takes to
Projection.
believe in some of those things. And we're going to talk a lot about the genome and some of that as well. So with Darwinian evolution, the supposition is that complex forms evolved from simpler forms. So
define complex and simple, because again, evolution doesn't necessarily favor more complex. It can favor more energy efficient, which would be simpler very often.
What is the evidence for this, right? So you would imagine that if more complex forms evolved from simpler forms, that in the fossil record, you would find simpler forms and then more complex forms.
Not necessarily. The simpler something is, the harder it is for it to actually fossilize. Fossilization itself is a very tricky process. I'm not an expert on it, but, there are a number of things that have to go perfectly right in order for fossilization to happen. It is a really cool thing that we have any fossils to begin with, but the thing we need to kind of deal with is the fact that we see change over time in the composition of life on Earth, and that's what evolution is about.
Over long geological periods of time. Geologic time is very long. We're talking millions, billions of years, right?
Any transitional forms?
And these transitional forms, right? So
everything is a transitional form. Give me a second. Alright. Back at it we go. Not that. Not that. Oh, Jesus. No, I don't want that. Nope, not that. Here we go.
You would see these simple, sometimes they are called transitional forms, which are hybrids, right?
A transitional form is not the same thing as a hybrid.
You would see, certain animals that.
I love how when these people want to talk about evolution, they're only talking about animals. They conflate animal and organism. Animals are a subset of all living organisms, but they're not the only living organisms.
That had some attributes of a later kind and some attributes of an earlier kind.
Two things. One, that doesn't make it a hybrid. Hybrids have to come from things that exist at the same time, by definition. But anyway, how do I put this? Remember when I said that once you're in a category, you can't really get out of that category, but you can make a new category that still fits within that category? So all of the newer organisms are going to have all the characteristics that make them part of their older categories, plus new ones.
You'll be able to trace the sort of lineage of these. And so in Darwin's day, they understood that the smallest form, the smallest living organism in everyone's bodies are cells, right? They understood this cell.
Yes. Sorry, I was reading about something. Yeah, cells were the basic unit of life. We knew that back then.
But in Darwin's day, they didn't actually know the inner workings of the cell.
Correct.
They hadn't discovered DNA or the genome. They just thought of cells as sort of like gelatinous blobs.
That's not totally inaccurate.
Is kind of what they thought in Darwin's day. And they also didn't have much in the way of the fossil record with regard to transitional forms.
Remember, everything is a transitional form because evolution is a process that hasn't stopped happening.
Or proof within the fossil record of Darwinian evolution.
I swear, when somebody's talking about science and they use the word proof, I can't really take them seriously. Because, well, proof isn't a word we use in science. Okay. Thank you.
And Darwin himself actually, questioned this, but he just assumed that over time we would find this, that archaeologists and so forth would find evidence in the fossil record.
And now we've gotten to the point where we don't even need fossils to vindicate evolution.
Of these transitional forms. And there are quotes of Darwin's, and I'll paraphrase here, that says if we...
Is this paraphrasing or just dishonest cherry picking of quotes? Quote mining.
Don't find this, then my theory should be essentially thrown out. But
should be.
He fully expected that they would find over time these transitional fossils. Right. So Darwin stated in 1859 in *The Origin of Species* that lack of transitional forms in the fossil record, he said, was the gravest objection which can be urged against my theory. That was
at the time. That was probably correct. Aside from religious objections.
His exact words. So if transitional forms aren't found, the theory should be thrown out. And an evolutionist today would say, but we found transitional forms. Of course we
did.
Found transitional forms. These transitional forms are in museums, and they're in textbooks, and they're taught to school children.
And some of them are still in the ground. And some of them are still walking the earth today.
And so, they would say things like, what about Artie? And what about Lucy? And so I actually wanted to look up Artie and Lucy and what they actually found. And so we'll start there. So we're going to start with Artie.
Ardipithecus ramidus, I believe.
Artie is an example of supposedly a common ancestor of humans.
I don't like the wording there. It's part of the family tree that shared a common ancestor with humans, but there's not necessarily, it doesn't necessarily mean that this is the direct ancestor of humanity. It was one of the branches on the ever-growing, ever-progressing, if you will, tree.
And this is a rendering that scientists have put together.
That looks more like an artist rendering than a scientist rendering, but I'll let it slide.
Of what Artie probably looked like. And I say this is what they think that she looked like on purpose. Scientists postulated that Artie walked upright, and this would have required her to have a curved spine like a human. So, and I'll actually have a picture of this later. If you look at chimpanzees, which are supposedly one of our closest, ancestors.
Close relative, not ancestor. There's a difference.
They have rigid, arched spines, and this requires them to be hunched over and walk on.
The thing that's different about a Verbo vacation home, you always have the...
Okay, that's not... well, it's a very cute monkey. There's a chimp. Say, what about chimpanzees having to walk on all fours?
All fours, so they can't walk upright like we do, whereas we have sort of an S-curved spine. And again, I'll show you a picture of this. But they postulated that Artie walked upright.
Now remember that the shape and positioning of the spine aren't the only things that are indicative of upright walking or bipedalism. Okay, there are other things such as the shape and size and rotation of the pelvis and some other features of the feet and the knees and a few other things that indicate being bipedal. Also, the foramen magnum, or the hole in the skull where the skull attaches to the spine, will be positioned, instead of at the back of the skull, on the bottom of the skull.
Um, and would have had to have a curved spine. Our spine actually intersects with our skull in a different place than it does on apes and chimpanzees, great apes and chimpanzees as
We are a type of great ape, but go on.
well. It comes in on an angle in a chimpanzee.
It comes in on an angle no matter what. It's just a different angle.
And the angle in the back of the skull, but for a human it comes in at the base of the skull.
Not even gonna say it. Not gonna make a joke about the way he's holding his hand.
Right. Again, that upright, and this allows us to articulate our heads.
Everything can articulate its head for the most part.
From an upright position and so forth. And so these would be things that are required for us to walk upright.
More or less so. They're not necessarily required. They're later adaptations that make the process of walking upright less challenging.
And so you would imagine that in Artie's, the skeletal remains that they found of Artie, that they found evidence that she had a curved spine and that the spine intersected the skull at the base the way it does for humans, right?
No. I think that we would see evidence, judging by bone wear and things like that, where the animal could have walked either way, and, the trend would be more towards bipedalism. But remember, if it's transitional, it shouldn't, have a clear-cut, feature of one thing versus another.
This is what they actually found of Artie.
Yes. Now, I'm impressed that they're able to, build a rendering from something as incomplete as that. However, because neither of us are completely familiar with the science behind looking at skeletal remains, neither of us should really be judging what the experts in the field say. Because, I'm sure there are plenty of things that this guy takes the scientific authorities' word for. Like he's using a laptop computer. That was, a scientific process to design that computer. And he's trusting the people who put that computer together.
So this is the.
I will say this PowerPoint that he's presenting right now is a bit better than that one on the first video. I don't see all the previews of all the other slides along the side.
Skeletal remains of Artie. So do you notice anything missing there?
There are some things missing, yes. The fact that we have this many remains is amazing.
Her entire spine is missing. Her whole spine is missing.
One moment, please. What? Quiet. There have been over 100 fossil specimens of Ardilopithecus ramidus. Okay. We don't know everything about our early ancestors, but we keep learning more. Does the pelvis of Ardilopithecus ramidus support the hypothesis that it was bipedal? It's only suggestive, which is fine. But, like, just look, there have been 100 fossil specimens, not just that one, incomplete skeleton. There have been many, many others.
Missing. She has there are no spine bone fragments that were found. So the idea of a curved spine is entirely made up in the minds of the scientists.
So, what he's doing is presenting the things we know today about Ardilopithecus, but making it seem like we based all that on this first specimen here. But that's not the case. We have found other specimens of Ardilopithecus throughout, the past couple decades.
And postulated by them that she must have had a curved spine. Also, you notice something else missing? The base of her skull. There's so many skull fragments missing that there's no bones that show where the spine intersected the skull.
Not in this specimen, no.
And so, and the skull fragments were so severely damaged, they don't have any that are where the spine intersects. The skull fragments also weren't found together.
That's perfectly normal if a scavenger was feeding on the remains of this animal.
They were found over a 30-mile radius.
Right. They were
Each of these skull fragments were found in an area covering about 30 miles.
I have a question. And, this is going to get, a little graphic. But let's say there's a murder. Let's say, a person kills another person and brutally dismembers the body, dissolves off the flesh and acid. Takes a sledgehammer and, breaks the skull to pieces and, drives down the highway throwing the bits and pieces of that skeleton out the window of the car. If you can trust that forensic scientists have the ability to piece back together those skull fragments, knowing that those skull fragments all came from the same skull, and how they go back together, it's a very complicated process that requires a lot of training. Why would this specimen be any different?
None of the skeletons were found complete, but they were pieced together from bone fragments found over this large area. The rendering was done through multiple digital extrapolations.
Yes, that's kind of what we have to go on. I mean, it's more than what you can say about the Bible.
Very scientific.
So they created her.
So they created her. They obviously have her feet, which they had rendered correctly, as you would imagine an ape's foot, which looks more like a hand. But they essentially created her.
So here's the thing. I think these people understand that, other primates exist. They don't even need to know all the primates that exist, but let's just say that we have a good conception of all the primates that exist, okay? If we know if they trust the science enough to know what the skeletal remains of every extant primate looks like, do they understand that, can we at least agree this is an extinct primate species? Because if we can at least agree this is an extinct primate species, and again, the reason I say that is because by comparing this skeleton to the skeleton of extant primates and knowing, okay, this doesn't match anything that is currently living today, we can logically deduce that this is from an extinct primate. Now, whether or not this fits into the hominid family tree is a different matter, but are they casting doubt on whether or not this is a primate? What do you think it is?
Out of whole cloth. Artie's brain was about the size of a chimp's. Her height was about the size of a chimp's. And so I think it's safe to conclude Artie was a chimp.
I mean, remember, we know what chimpanzee skeletons look like.
Bonobo.
That's why you're not a
A bonobo,
scientist.
exactly.
Walks like
And so, I think it's actually a safe conclusion that Artie was just some form of bonobo or chimpanzee, and was not really an ancestor of humans. So the next one that
Didn't he say a couple minutes ago that chimpanzees are one of our ancestors?
a evolutionist would probably tell you is okay, fine. What about, never mind Artie. What about Lucy? You'll hear the fancy name Australopithecus afarensis.
Yes, there's also Australopithecus africanus.
Yeah.
Which is Lucy, and all that.
Lucy is one of the many Australopithecus afarensis that exist. She's not the Australopithecus afarensis. She might be the type specimen, but she's not the entire species.
That's just fancy word. She was, I think there's an afferens
The Afar region in Africa.
area of Africa or something that they found Artie in. But
You mean Lucy?
Lucy is hailed as Darwin's as proof of Darwin's theory of evolution.
No, she's not. I've never heard anybody, put this one specimen up on such a pedestal.
It is a transitional form discovered. Game over, creationists.
Allegedly.
It is proof that
It's not the only alleged thing going on.
Darwin's evolution is true. So I decided, well, let's take a look at Lucy, right? Let's see what they discovered about Lucy, since she's considered a prime example of ape to human transitional form. And so let's.
I mean, ape to human is a non sequitur because humans are still classified as apes.
Actually, before we get to that, I wanted to. This is the example of the curved spine versus the arched spine of chimpanzees. So you
Okay. I can see that.
can see in a chimpanzee or a bonobo, you would have the spine entering on an angle into
They're both entering on an angle.
the skull, and it would be sort of rigid and arched, versus a human spine, which goes in at the base of the skull and is curved around. So that's what when I was talking about curved spines versus arched spines, that's what I was talking about. But let's take a look at Lucy. This is Lucy.
No, it's a depiction of Lucy.
So Lucy, this is what scientists think Lucy looked like. Now notice they gave her white eyes, right? So we have our cornea and pupil, and we have the white part, the eye whites, right?
Chimps don't have
And
that.
chimps don't have that. I've got a picture of that here in a second, but they obviously didn't find any biological material to prove that she had
They didn't find soft tissue, they found biological material.
eye whites. So they, again, just made that up to make her look more human. Notice something else in this picture. Look at her feet. Her feet also don't look like chimpanzee feet. They look like human feet, right? The chimpanzee feet look
Hands.
like this, right? So the chimpanzee is on the left and human foot is on the right. Again, eye whites for humans, and sort of they have this dark color around there for chimpanzees. So in the picture of Lucy, I'll go back, you can see she has the eye whites and she has feet that look like human feet.
Now remember, this is an approximation. It's not necessarily, a dogma that she looked like this.
Right? So they obviously must have found a lot of evidence for this, right, when they found Lucy's remains, right? What do you think? Any guesses? This is what they found.
Again, of this particular specimen, correct. But it's not the only specimen of this species that we have found.
This is what they found of Lucy. So what do you notice missing?
Everything.
No, there are some ribs missing, some leg bones, some toe bones, part of the skull.
It's called
Feet? There's no feet! There are no foot bones in this entire skeleton! Not a one!
Now, one of the things that you can deduce, however, by the pelvis shape and the shape of the connection piece of that ball and socket joint, that's, the the top of the leg. Is it a femur or a tibia? I believe it's a femur. Suggest upright walking.
Not a single foot bone. They have almost none of the skull. So her eyes obviously couldn't be found because the skeleton is considerably old. So biological material doesn't last that
The fossil is still biological material, remember?
long. We know that. So the eye whites were something that scientists made up. They extrapolated. They added to make her look more human-like. There are also no foot bones. Not a single foot bone. So again, how did they determine that she had feet that looked like human feet
By looking at other specimens of this species.
rather than feet that looked like a bonobo or a chimpanzee? They didn't. They had to make it up. There was a BBC documentary about Lucy where they talked about 400 specimens of Lucy's species being found.
Yeah.
Right? So 400 specimens, that's a lot of specimens. So maybe this is just missing some of the stuff that they found with the
Yes.
other specimens, right? But do you think they actually found 400 skeletons?
A specimen is not a skeleton, necessarily, so no.
Nope.
No, they found 400 bone fragments, and 30% of those were teeth.
That still leaves, what, let's see, 30% of 100 is 30, so 30 times 4, 120, so that still leaves over, 280 non-teeth.
That's what they found. They found 400 bone fragments that fill up about the size of a picnic table. Not specimens, unless you call a bone fragment a specimen.
Yes, that would classify as a specimen. If you, go get a urine test, the cup of pee becomes a specimen.
So they didn't find 400 skeletons, they found 400 bone fragments. 30% of those were teeth. Lucy's skeleton was found on a hillside, not as a complete skeleton that was intact, but over a 3-meter area, which is about 9 feet for us Americans. After sifting about 20 tons or 50 square meters of sediment, and they
I think it would be cubic meters, not square meters.
only found about 20% of her skeleton, which is what that refers to. Scientists essentially rendered the rest of Lucy to make
Are they going to show all of the other specimens, as a composite?
her appear to be human. So they essentially said this is what she must have looked like. They didn't find any evidence that that's what she looked like. They just sort of made it up as they went. Also, Lucy's face, right? It looks a little less chimp-like. It looks a little more human-like, right? Chimps have a much more sloped forehead. Now it is sloped, but it appears to be a bit more human-like than chimpanzee-like.
I don't think they're going to do this. So they have what looks like the lower jaw. Looks like they have complete skulls. Come on. What? Here we go.
So, how much of her skull did they find, right? So let's see. The brown stuff is what they found. The white stuff is what they extrapolated
I mean, remember they found other skulls.
from the brown stuff, right? So, they didn't really find a whole lot of her skeleton. They rendered almost everything, but they touted as if it was science.
I mean, you guys aren't really science people either.
As if it was fact. And it's just silly, right? I mean, how can you come to any conclusions based off of what they found?
You can't. What year were these two things found?
Oh, I don't know.
I think, what, 1964? I mean, like, I feel like they should know this. Discovery date 1974. Okay, close enough.
I could look it up, but I don't know.
Tony Fauci had to be involved.
This was not found during the affair. I will tell you. So, why the attempt to tie humans to chimpanzees, right?
It's not really an attempt, it's just the fact that we are related to chimpanzees.
Or to bonobos or to great apes, right? And by the way, I've littered this talk and the talks we're going to have over the next couple of weeks with videos as well. You're not going to just listen to me drone on.
Thankfully.
I do want to, inject some videos in here for you guys because you guys seem to love the videos that I did during the origin of the universe. So I figured I'd throw some of those in. Some of these are from some of these are secular videos, meaning not theistic videos.
Secular and non-theistic are not the same thing.
But the fact that some of these videos on the nose say things that I'm just like, and you still believe this? I thought was shocking. But why the tie? Does anybody know why people want to tie us to chimpanzees?
Sorry, something's moving in my room. I just heard something move.
These are great apes. Has anyone heard a reason for that?
Let me guess, we're going to talk about abortion.
Oh my God, existence.
Well, there's certainly the anti-theistic or naturalistic tendencies, but why chimpanzees? Why not wolves or whales?
Because we're not evidently, we're related, but we're not as related to wolves and whales as we are to chimpanzees. Remember, I said we have these categories. We are more closely related to a chimpanzee than we are to a wolf, but we're more closely related to a wolf than we are to, a fern, for example.
Isn't that like a 99%?
98%. The 98% is the section that I called this one. Spot on. So there's a claim that we share 98% of our DNA. So they discovered the genome, right? Which we're going to get a lot into that later on. But they discovered the genome, or human DNA, or DNA generally, right? They discovered that every cell has DNA,
Red blood cells don't.
right? And then they came out with a claim that humans and chimpanzees are 98% the same in our DNA.
We share 98% of the same DNA, yes.
There's only a 2% difference between our DNA and chimp DNA. So decided to look into that, right? Let's see.
I mean, remember, 2% of, hang on a second. How many base pairs? Okay, 2% of 3.2 billion. Should we do the math? Should we do the math? Let's do the math. Okay. $3.2 billion. Times 0.02. That is still 64 million base pairs. Now, okay, the average gene is about 3,000 bases divided by 3,000. So you still have, more or less 21,000 genes that are not the same between us and chimps. Is that really that big of a surprise?
Let's see if that's true. So just to talk a little bit about DNA, which we're going to get into a lot more of DNA later on, probably in next week's session. We have one.
Oh, they have another session? Okay, not that. Hang on a second, folks. Nope. No. Don't want to listen to that garbage. Oh, here. The fuck? No, I don't want to play. Oh, god damn it. The hell? Oh, they haven't released a part 3 yet. How long ago was this posted? Oh, just 9 days ago. Okay. Whatever.
Next week, right? And the congregation meetings the week after, yeah. So next week we're going to get into the genome, and we're going to get into some of the details of the genome and some really cool videos as well about what was termed biological machines. There's actually nanobiological machines in our bodies, which is pretty cool. But they discovered DNA. Now, just for perspective, DNA is the double helix that you'll see a lot of times, and it's comprised of nucleotides and what they call base pairs. There.
Nitrogenous bases. A nucleotide is the nitrogenous base attached to the deoxyribose sugar and a phosphate group. Okay, that's a nucleotide. The DNA is made up of nucleotides, which themselves are made up of nitrogenous bases, and because it's a double helix, that makes base pairs. Now, you have two types of the four. You have four main nitrogenous bases: guanine, adenine, cytosine, and adenine. Two of those are called pyrines and two are called pyrimidines, and you can only get pyrines bonding with pyrimidines. You can't have a pyrine and a pyrine or a pyrimidine and a pyrimidine, but there are also several oh yeah, there's uracil. Okay. So you have other nucleobases. You have xanthine, hypoxanthine, purine, 2,6-diamинopurine, 6,8-diamинopurine. DNA and RNA contain non-primary bases, such as this guy. Woo! 5-methylcytosine, pseudouridine, dihydrouridine, inosine, 7-methylguanosine, hyposanine. So I don't want to, again, I don't want to be, overly, I don't want to, grill them too much on that, but, just keep in mind that it's not really just, ACGT, there are others that exist.
Their bases, which are the central spine of the DNA, is a set of protein base pairs.
They're not proteins, they are, nitrogenous bases, they're compounds. Remember that to be a protein, you have to be comprised of amino acids, not nitrogenous bases, and you need to have a multi-layered structure that these molecules just don't have.
Now, a human...
Now, the DNA does wrap around proteins called histones, so that's a different matter.
DNA, so this is in the nucleus, in the nucleus of every cell.
Not in red blood cells, and also that's not in the nucleus during mitosis and meiosis divisions.
There is DNA, right? This molecule. Humans have 3.097 billion, with a B, base pairs in the double helix DNA of a human cell. Chimpanzees have 3.231 billion base pairs in their DNA.
Yes. So the exact number of base pairs doesn't have to line up perfectly to suggest relation between the two species. Okay? Just putting that out there.
So 3.097 versus 3.231 billion base pairs. That's many billion. That's many difference, right?
What? It's about 150 million. When it comes to numbers of base pairs, that's really not a lot. Especially when you realize that, most of the DNA doesn't actually code for protein.
Many millions of difference. So this makes chimp DNA 4.3% larger than our DNA.
Woo! A whole 4.3%. Oh boy. I'm convinced. I'm gonna be a creationist now.
Right there, you're already 4% off. There's no way we could be 98% the same.
There still is a way. Okay? Nobody's asserting that we're 100% the same. Okay? Remember that, 2% still has that, difference between the two sizes of the genome basically covered.
So how can we get to this 98% similarity? So what they did was, and we'll talk more about the structure of DNA and the actual digital code that's in it, but
Digital code?
what they did was they decided to break chimp DNA and human DNA into chunks. Kind of like, think of it as a book, right? And we'll show a video where they're actually going to go through this, but you think of it as a book.
Just a second. Sorry about that. I heard some rustling. I don't know if I think there's a mouse in my room. I gotta set a trap.
Where they broke down it into different chunks, and then after they broke it down into chunks to make a comparison, they excluded 25% of the human genome. So they just threw out 25% of human DNA, and they threw out or excluded 18% of chimp DNA. These were things like repetitions and in the DNA and stuff that they just decided wasn't important. And then they took all the parts that didn't match up or make sense and just threw them out.
Called junk DNA.
Yeah, they called it junk DNA.
Again, junk DNA and non-coding DNA are different things. We've been through this. I think they're misrepresenting the whole process. But let's call it there. I've got stuff I gotta do. Okay. I got a little distracted. Why don't I'm gonna go through and just kind of edit out some of the ending, and then I will kind of rewind in the next part, so that we can actually go through the process of like determining, how two organisms are genetically related and things like that. But do you remember, when they talk about, what percentage of DNA we share, the process isn't perfect, but science isn't perfect. So, I gotta take care of some stuff. I have plants and some animals to tend to right now, and then I gotta get going on some school stuff. So why don't we call it, and I might be back working more on this later, maybe tomorrow. I don't know yet. But thanks for tuning in.